For homework 9.3, just write down some of this work, show me the words that you listen to get you ready for the weirdness of next week. We're going to be looking at specific sequences like this: 4, 7, 10, and then lucky number 13. That's all they're going to give you, and they're assuming that you could do everything else. So what we're going to do it like this. We're going to say this right here is term number 1. The first thing listed is the first term. If I get that in red. First term, second term, third term, fourth term. So that's what we're doing. We're assigning values underneath the numbers. And of course, those are like your X values. X is 1, Y is 4. A little trickier because the numbers are on the bottom to represent the terms. You will still have to go back to the 0 term on these. So I'm going to have you see that I'm adding 3. That means going reverse. I take that 4 and subtract 3 and get 1. All right, now we're going to be looking at writing equations for this. There's going to be 2 of them. First one's called recursive. And that looks like this. I could find any function in the sequence by taking the 1 before it and then adding or subtracting that number. I know what it is, and we'll call it plus D. That D number is the number that you're adding each time, that 3. So the recursive formula for this, I would write as f of x, first word is cat. I would write f of x equals f of x minus 1 plus that 3 number right there. I could use this to find any number in the sequence. The 5th term, let me show you. 5th term, 6th term, 7th. You should see that the 5th term, adding 3 gives you 16. Adding 3 more gives you 19. That is a recursive pattern. Using the number before it and adding 3. To find the 5th term, I use the number before it, added 3. To find the 6th term, I use the number before it, added 3. The way that looks in function notation is this. To find that 5th term, I plug in an actual 5 in there in the X spot. My pen writes. So you take that and say that the 5th term comes from the 4th one plus 3. And what do I say for the 4th one? Now you need to actually see, this is the 4th one. That's f of 4. You plug this 13 right there. That replaces this. So to find that 5th term, I use the 1 before it, the value of the 4th, which is 13, plus that D number right there. So that is the function way to show me that that 5th term is 16. It's called recursive. To find the next term, you use the 1 before it and keep adding the number that you know. That's all this is. It looks fancier than it is, but that means to find any term, you use the 1 before it and add D to it. If I want to find the 5th term, use the number before it. 13 plus 3, 16. If I want to find the 6th term, use the number before it. 16 plus 3, 19. This formula is used when you're going from one to the next in a sequence. It's called the recursive pattern. When you're going from one to the very next step, you don't need a fancy formula because you know the number before it and you know what you're adding or subtracting. It's called recursive when you're going from one to the very next term. But of course, if you're jumping ahead, the second word is moose. Moose. If you're jumping ahead to like the 20th, now you need to use what's called the explicit form, and that's the one that we've been practicing. So we're going to use the zero term explicit. The explicit equation comes from me timesing the number I'm adding times x plus the function at the zero term. That's where it gets all fancy. So that just means that 3 number goes right here, and that zero term, whatever that is, number goes right here. So again, same thing we were doing. To write the explicit function for this, it's f of x equals that 3 number in front of x like we've been doing, plus that y-intercept number right there, the value when you plug in x is 0. And of course, you could use that to evaluate for the 20th term. Gives me the 20th term equals 60 plus 1 equals 61. Third word is donkey. Good luck.